be a gateway tomorrow.
Okay, bye.
Bye. All right, Alicia, you have access now, so you probably didn't have access before. So we have some guesses I'm seeing. Emma, you have 3,600. Good job. Keys, 22 to 2,300. Okay, good. And Nikisha, 3,000. So all very close. Jazz has left the building for now. So let's actually look. Let's compare. Let's see how we do this. All right, you guys. So my hint to you before was that it was like slope, right? Slope. Okay. So if we think about what slope is, and we've talked about this before in one of the weeks, but we're going to keep working on it because we are now starting with graphing and lines and all kinds of equations. So you're going to see a lot with slope. So let's actually review slope. So slope is, we sometimes call that m. And if you guys remember, it's your rise over your run, right? Okay, good. So another way to think of rise is that's the change in your y values, right? Because rise is your y values. So if we change our y values, we can think of it as, so whatever point you're on, y2 minus y1 is the change in y values. And then x2 minus x1 is the change in x values. Okay, so that's how we look at rise over run. So basically when you guys are graphing, when you go between 2 points and you count how many spaces up you go, that's figuring out the change in y. That's y2 minus y1. And then when you count over for your run, that's figuring out your x2 minus your x1.
Okay, question. Okay, so when it rises and runs, so like, say you have like a table or a graph, so when you have the x-axis and the y-axis or whatever, so you take like your, wait, y1, y2, what is that, like your initial and then your final?
You can actually pick any 2 points you want.
Okay.
Any 2 points. But you're exactly right. So Emma was talking about making a table and the points you pick. So actually that's really good, Emma. We're going to make a table. So I'm going to make a table for this data, and I'm going to have x and y because that's a really easy way to do it. Okay. And hang on. We're going to have to quit this so it's not on here. Okay. So if we look at what we have, you guys, so the 200, that's just a starting amount, right? This isn't a point. This is just a starting amount. So we're going to ignore the 200. What we want to look at instead is day 1. So day 1, the creek was measured at 1,800 cubic feet. So we've got that point. And then day 3, the creek was measured at 4,800 cubic feet per second. So those will translate into points. So it's kind of like when you're looking at patterns and you have the first pattern, second pattern, third pattern. It's the same type of thing. So our first day, so I'm going to put a 1 here, our y value was 1,800 cubic feet. Okay, and then we don't have any values for our second day, but if we did, we could write that in here. But we do have our third day, which was 4,800 cubic feet. And all we need to make an equation or to find slope is just 2 points, any 2 points on a line, because the slope has a constant rate of change. So when we're figuring this out, we're going to take y2 minus y1. So we can pick either one of these to be our y2. It doesn't really matter. So Emma, maybe this was kind of your question. Our first one could be our y1, and our second point down here, 4,800, could be our y2. And then as long as we match that over here. So for example, if I call this point up here my x1, then this one over here has to be my y1.
Okay.
And so, but you can pick any points you want. So if I do that and say 4,800 is my y2, then I'm going to take 4,800 minus 1,800. Okay, so that's going to be my change in my y's. That's going to be my rise. And then I'm just going to do the same thing for the x's. So 3 minus 2. That would be x2 minus x1. So when you subtract, you get 3,000 over 1. So my average rate of change is 3,000. Oh, wait, what's 3? Oh, sorry, you guys, I wrote that wrong. Sorry, let me erase. It's actually not over 1 because it's not a 2 down here. Sorry, make you guys erase. It's 3 minus 1, right? Because our x1 is 1, not 2. So it's 3,000 over 2, which gives us, now we have to divide, 1,500 cubic feet per second. So that's our average rate of change every day. So the river is increasing in intensity by 1,500 cubic feet per second every single day. Is really, if we followed that pattern, it would continue that way forever. But hopefully the rain would stop, and then we wouldn't continue to increase our river speed. Okay, so that's how you find the average rate of change. And when you guys do that, remember to always divide your slope out. This came out nice and even, but if we'd had 3,000, say, divided by 6, or well, that would come out even too, 7, let's say, we would have, some number with a decimal, and that would be okay too. The other thing with rate of change is make sure that you always put your units. So this is 1,500 cubic feet per second, and then it's per day, right? Per day. Okay, because the x's represented days, and then our y's represented our cubic feet per second. Okay, so any questions on that? If you guys have any questions, type it in the chat box, and then I'm going to go over and see if you guys have questions. So, no questions that I see. Marquise, how you doing over there in the other room? Hopefully you're all good. Alicia, you're still with us? All right. Very good, guys. Very good. Okay. Excellent. Excellent. Okay, so we're going to continue on with our problem a little bit, just with some graphing, because like I said, we're going to be getting into the graphing and stuff. So let us continue. So what we're going to do is we're going to take and we're going to make an equation now to represent the increase in flow over time based on this information and the average rate of change that we found. So if you guys remember that the average rate of change was 1,500, right? So if we want to make an equation, it has to be in that form of y equals mx plus b, because we're just working on linear equations right now. So we know m. We know that m is equal to 1,500, okay, 1,500 cubic feet per second and every day, right? So x would be however many days. But now we need to figure out b. So does anyone, if you go back, and I'll go back, maybe. If we go back to the, oh wait, we don't need to go back. Sorry, it's right here below us. Here's the problem down here. Does anyone know what b might be? What value we would give for b? And think of b is your y-intercept. B is also the starting point.
200.
Yay, 200, yes. Good job, everyone. 200. So 200 is the starting point. So what's kind of cool about this, you guys, is that once we have an equation, we can graph it, and we can see what the trend would be over time. And that's how, like right now, they're evacuating a couple places up in the north and east. Have you guys heard about that? I mean, it's not raining, but the problem is the river is increasing, it's flowing, it's rising some more, and they're predicting that it's going to be over a certain level, and they know at what level is the flood zone, right? So if they can predict that it's going to go over that, they're getting all these people out because they predict that it'll hit there today, sometime later today. And the way they do that is the same thing that we're doing, is they make graphs and they do predictions. So if we look at a graph of this equation, y equals 1,500x plus 200, this is kind of what it looks like. So assuming that we have constant growth, right, it grows at the same rate, then you can see, like, after one day, well, here was that 1,800 we were talking about right here, right? And then here's our 200, our starting amount. And if we continue on, well, we said it was at 4,800 after day 3 or something, so that was this point right here. So if it continued to rain or the river continued to rise at a constant rate, that's kind of the key, we're assuming constant rate, then we can figure out, wow, what would it be after 5 days, because we can just look on our graph and we can see how high or what the rate would be after 5 days. So let's actually fill this out in case you guys can get used to graphs. So this is a graph of that equation. So what would you guys say the title of this graph would be? So everybody type in your notepad, what would you want to title this graph? You can make it anything you want. It's free. It's not even math. It's like English. Just come up with a title. It's like a title to a book.
I don't know.
I mean, you can come up with any title you want. It's like being an author. Keisha, how about you?
It's hard.
All right, you guys, I'm going to go over and see what you're saying because I can't see on my screen for some reason. Weather. Okay, Keith said weather. Rising river. Alicia, you not have anything on there. I don't know who student 2 is, but that, oh, maybe that's me. Is that me? Why didn't we get evacuated? Oh, well, that would only be if you were in danger of getting flooded out, Keys, you know. So if you were fairly safe, then you would be evacuated. Only if you were in danger. Oh, you were. You was? I thought you said you weren't. Hmm. I thought you were in a hailstorm or something.
That hailstorm was crazy.
Oh, in your mind, Keys, in your mind. Ah, yes. The hailstorm, yes, that was kind of crazy. Very crazy, you guys. Hopefully you all are not displaced from your houses. Are you guys all in your houses still?
Yeah. But yeah.
Yeah, did it get flooded?
No, but if it does, we don't have any of our equipment now because it's at everybody else's house.
Your equipment?
Well, my dad's like he does
Oh, for
carpets,
the
so
yeah, for the vacuum cleaning the carpet stuff.
Mm-hmm.
Yeah, hopefully not. How about you, Nikisha? Are you good? Are you in your house still? Okay, that's good.
This guy in my class at CCA, his house is gone. He's like, my house is gone. I was like, what? It's not there anymore.
Oh,
Oh my
no.
gosh.
So yeah, that's happened to a lot of people. It's very sad. Well, you guys, okay, so Rising River. I got that from a number of you. Thank you to Alicia. I got yours. So we'll just call this, we'll call this Rising River. That sounds good. Okay, so as long as it describes the relationship between the x and the y. So actually, before we write that, you guys, so our x-axis we said was days, right? This represented like how many days went by. And our y-axis represented the cubic feet per second. So we could also call this the rising river in cubic feet per second, per day. But that's a lot of writing. So we'll just call it what you guys were saying, something about the rising river. So whenever we do graphs, and just so you guys know, whenever you're taking any tests like your ACTs or your TCAPs and all that, anytime you have to make a graph, make sure that you record what your x-axis is and your y-axis, because they do give you credit for that, and they take away credit too. So just any kind of test you do, even if you do an AccuPlacer, for college and stuff, anytime you do a graph, make sure you have titles and labels. Okay, so determine what the flow would be after 5 days, assuming the trend continues. All right, so if we're checking this out, if I go over here on the graph, what's really nice is I can come right here and I can say, okay, well, here's 5 days. If I look, it's pretty close to 8,000 cubic feet per second, just shy of it. So that's one way I can do it. And if you have this on a computer and it's all programmed, then it'll just calculate it for you. But the way it calculates it for you is it actually takes the equation. So you have that y equals 1500x plus 200. So remember that x represents days. So if I want to figure out what our rate is exactly, I'm just going to take and I'm going to plug in that 5 days in for x, because x represents days. And then I'm going to solve. So 1500 times 5, that is 7500 plus 2, 75, 76, 7700. So that is what our y would be after 5 days, assuming that it kept raining. So thank goodness it stopped, actually. All right, so you guys, how are you doing? Any questions on that at all? Anything like that? Comprehension? Here, we're going to come back over. Alicia, no? I don't know if that was now, or was that now or earlier? Alicia, is that no? No? Okay, good. So no questions. Okay, good. Nikisha, how are you doing? Are you good? Okay. I know you're good. I'm sure you're good. Okay. All right, you guys. So let's actually move on a little bit more. Let's look at this again, different perspective. So one of the things you guys are learning now in this week, or last week, if you've come to it, and this week too, is we're talking about domain and range. Okay. And if you've watched the lessons, and I'll review in case you haven't, domain is always going to be our x-axis. So all the x values represents our domain. And then our range represents our y-axis. So this is going to be really important as we move on, because sometimes when you're answering questions or you want to know, what are the answers, you would always then maybe either look at your domain or your range to find your answers. So you're going to have to be able to identify domain and range. Okay, well in math, assuming that this isn't the graph of this river running, in math this would just be a line, right? So on both ends we would have arrows, and that means that this would go up forever, right? And it would go down forever. Well, if you think about this, so this is going up forever, but it's also going to the right forever. And it's also going to the left forever. And again, you guys will see this when you watch the video on domain and range, but out to the left, eventually you get to something called negative infinity. Have you guys all seen that before? Infinity? The infinity symbol? Yeah. Mm-hmm. Yeah, that was a rough sketch. It's all right, Emma. Just put 2 zeros together. You'd be good. See? You could do 2 zeros. Or you can make a little. But out to the left is your negative infinity. Out to the right is your positive infinity. If you come down on the y-axis, you get to negative infinity. And if you go up, you get to positive infinity. So if I look at this graph and I want to do domain, okay, so let's do domain. We'll do pink domain. And I want to describe my domain. My domain goes from, and I'm going to do it with interval notation, and you guys will read the difference between interval and algebraic notation. But my domain means that this line is going to hit every single number out to the left, right? It's going to go out to negative infinity, basically, because it's never going to stop, just because lines don't do that. So the domain is negative infinity to the left, and then to the right, this line is going to the right forever also. It's never going to stop. So in my domain, I'm going to have negative infinity to positive infinity. And so mathematical domain, that's what that would be. If I do my range, though, it's really not going to be any different. Because if you think about this graph, right, and we always go smallest to biggest, it's going down. So it's going down, 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 down. It's never stopping. It'll actually go out to negative infinity, just that direction. And then if we follow it going up, we would just keep going up forever too. We would never get anywhere. We would just continue on up to positive infinity. So when you think about the domain and the range of a line, any line, the line is going to actually eventually hit every single number on y and every single number on x. Okay, so that's our domain and range. And again, you guys, this is interval notation, but you can also do it using inequalities. So when you do this lesson, you'll see how to do it both ways, and you can use whatever way is more comfortable for you. Okay, so I have this second problem here. It says determine the domain and range based on the scenario. Okay, so if we think about our scenario, negative numbers don't make any sense, right? The river can't flow negative. Okay, and if we think about the starting point right here, that was 200. Okay, so if we're thinking about our range, the river starts at 200, but it could go up potentially forever if it rained forever, right? If it never stopped raining, it could go up and up and up forever. So I'm going to do range first. So if we think about the range, we actually are starting at 200, and I'm doing a bracket. That means we are including that number 200. But we're going up, 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 up forever, assuming it rained forever. So we go from 200, and that line will continue up forever to positive infinity. So that is our range. Okay, so now let's think about our domain. So domain has to do with time. So if we're thinking about this in real life, we don't have negative days, right? We can't go backwards in time. So we would start with day 0, and again I'm doing a bracket because we would include 0, but it would go also to positive infinity forever. Okay, so our range, oops, see if we can highlight both at the same time. So our domain and range for a real situation looks a little bit different than a mathematical situation. So I just want you guys to be able to distinguish the difference between math and then if we're really identifying something in real life, because math doesn't have start and stops necessarily based on any situation. It's just mathematically what does a line do? It goes up and out forever, and it goes down and out forever. Whereas if we actually have a real situation, well, we're thinking about a river and we're thinking about time. Time can't be negative, and the river also can't have a negative flow. It makes no sense. All right, you guys. So any questions about that before we go to our last slide? Any questions? I'm going to go back over, see if you guys have any questions. Let's see. Keys, how are you doing? And Alicia, who are not with us. Thumbs up. You're good. Keisha, Emma, how about you guys? So any questions at all? Nothing that you want to go through? Okay. All right, you guys. All right. Going down to our final slide. Okay, final slide. Is everybody ready for this? Okay, so transformation is the very last week that we just, or this week, I guess. This is this week. I feel like this week is over, but it's not. So we start with linear equations because they're the easiest. And I know that some of you guys haven't gotten to that lesson yet. So just so you know, we have something called a parent function for every function. And the parent function is just a really basic function. So for a linear function, it's y equals x. So anything you add to that is called a transformation. So if we compare that with the one up here.
Sorry, I accidentally kicked off my wireless switch.
Emma, did I get you back in?
Yeah.
Okay. So if you look at this one up here, the 1500 and the 200, those are extra things. That's not part of y equals x. And y equals x is called the parent function. So you guys will see that when you're looking at the lessons. So what we have to do is look at what the 1500 does and what the 200 does. Well, if you look at our graph, the line goes through 200. If you think about what the parent function would do, the parent function would go right through 0, 0, right? Because there is no plus anything on the end. So first things first, if we think about this 200, so let's analyze the 200 as far as transformations go. The 200 basically says that we have to shift our parent function up. So that's a shift up 200. So that is one transformation. Okay, so that number on the end, that y-intercept, it just tells our graph where to go. Does it go up from 0 or does it go down from 0? And then the last transformation we have is this 1500. And if you guys think logically about what that does, that makes the graph more steep, right? Because if you think about rise over run, we go up 1500 and then over 1 to right here. So it made our graph much steeper than our parent function where our slope is just 1 over 1. So we would go up 1 over 1 and plot our point. So that 1500 made it steeper. So the way we write that as a transformation is we call it a stretch because the graph stretches up towards the sky. So it's called a stretch of 1500. So we always have to put the numbers on there too, just so that you make sure that you know which one you're talking about. Okay, those are just 2 of the transformations. There's actually 3 with linear functions, and you guys will get that too if you haven't already listing those. So are there any questions on the transformations, or anybody who's gotten to that already that has questions, or if you haven't gotten to it but you have a question? Anything? You might later.
But well, yeah, later probably.
Later.
Like, I mean, I get it and everything, but then I try to like usually apply it to like other scenarios. Like I get like halfway through it or something, and I'm like, wait, I'll get stuck on something.
That's okay. Yeah, just let me know. And you guys make sure to. You can also message me in Schoology and I can explain it. I usually do a pretty good job, or we can even do a webinar together, just you and me, kind of a thing. So let me go back over, make sure. So you guys. Keith, Alicia, that's pretty much it, unless you guys have any questions. Are you guys all good? To carry on? Okay, so while you're typing, just see if you have any questions. I just want to point out to you guys. Oh, that's Gucci. I don't know what that is, Keith, but I'm just gonna assume that means you're good. Okay, this is good. Yes, sir. Okay, that's good. I'm a ma'am, Keith. I'm a ma'am. But anyway. You guys, 3 weeks left in the quarter is all, only 3 weeks. So you definitely need to get through the unit test. And if you guys started late, I know, Keys, you did start. That is very good, Keys, much better. If you start late, then just make sure you're kind of up to date with the weeks so that when the quarter ends and I give you a grade, you get a good grade and not a bad grade. So all of you guys, make sure, really, really important, because the quarter's ending, is get caught up if you're not caught up. All right, you guys, that's it. Thanks for coming. see you guys next week or in the lab.